Welcome, space enthusiasts and curious minds. Today we're delving into a thrilling question. Has the James Webb Space Telescope, JWST, found alien life in K2-18b? K2-18b, an exoplanet located in the habitable zone of its star, has been a subject of fascination. As we embark on this cosmic journey, let's uncover the secrets revealed by the JWST about this distant world. Prepare to be amazed by the latest findings and what they mean for the search for extraterrestrial life. Ever since its launch in 2021, the public has been deeply intrigued by the James Webb Space Telescope, JWST. This interest goes beyond its ability to gather data about distant galaxies or the origins of stars. The focus is intensely set on one question: when will the JWST find evidence of alien life? This isn't an outlandish query. Finding signs of extraterrestrial life is one of NASA's objectives, whether that's a microbial fossil in Mars's ancient lakes or a simple life form in the subsurface oceans of Europa. However, the JWST's search for alien life might be on a faster track. In September, researchers using the JWST made a potentially groundbreaking discovery in the atmosphere of exoplanet K2-18b, noting signs of water and a molecule possibly linked to life. With more observations planned for 2024, we could be on the brink of a significant discovery. But this has stirred skepticism among planetary scientists, revealing a major challenge for NASA. How can we be absolutely sure if we've truly detected signs of extraterrestrial life? The discovery of potential alien life by the James Webb Space Telescope, JWST, stands as a monumental achievement among its numerous findings. On September 12, 2023, a research team from the University of Cambridge, led by Professor Niku Mutahan, unveiled their groundbreaking observations of the exoplanet K2-18b. Located about 120 light-years away in the constellation of Leo, K2-18b caught the attention of scientists in 2019 when the Hubble Space Telescope hinted at the presence of water vapor in its atmosphere. This prompted the Cambridge team to focus the JWST on K2-18b, but the findings exceeded all expectations. The results revealed the presence of methane and CO2 in the atmosphere of this distant world, coupled with an absence of ammonia. National Geographic highlighted that, according to theoretical research, a large planet like K2-18b could exhibit such a gas ratio only if its atmosphere were interacting with water beneath it. This led to the speculation that K2-18b could be an ocean world, enveloped by a vast sea unlike any on Earth. But the discovery went even further. Alongside methane and CO2, the JWST also detected signs of dimethyl sulfide, DMS. To understand the significance of this finding, Professor Mutahan's statement to the BBC is revealing: on Earth, DMS is only produced by life. Most of it in our atmosphere comes from phytoplankton. This observation opens up intriguing possibilities about the nature of life and its potential existence on K2-18b. In the quest to explore extraterrestrial life, the recent discovery related to the exoplanet K2-18b by the James Webb Space Telescope, JWST, has sparked immense interest. The detection of dimethyl sulfide, DMSA biomarker, often associated with marine plankton on Earth, was made in the atmosphere of K2-18b. Although the researchers have expressed caution, noting the low confidence in the DMS detection and the need for further observations, the possibility of alien plankton-like organisms has captured widespread media attention. This discovery comes at a time when NASA is deeply invested in the search for life beyond Earth. The Mars Sample Return mission, costing over $8 billion, aims to bring back Martian materials potentially containing ancient microbial life. Similarly, the upcoming $5 billion Europa Clipper mission is set to explore Jupiter's moon Europa, which may harbor conditions suitable for life. Therefore, the JWST's detection of a known biosignature on an exoplanet has fueled dreams and speculations among scientists and the public alike. However, before delving deeper into the implications of this discovery, it's essential to understand two key aspects. What is K2-18b, and how do scientists detect elements in its atmosphere from such a vast distance? To answer these questions, let's embark on an imaginative journey across the cosmos. We'll travel from Earth through the vastness of space to a distant solar system located 120 light-years away. In this solar system, we find K2-18b, an exoplanet that has become one of the most fascinating subjects in our quest to understand the universe and the potential for life beyond our planet. The question of what K2-18b is can be answered quite straightforwardly, though the details surrounding it remain somewhat enigmatic. At its most basic, K2-18b is an exoplanet located over 120 light-years away. It falls into the category known as sub-Neptunes, which means it is larger than Earth but smaller than Neptune. Specifically, it's about 2.6 times the radius of Earth, representing a size of planet that is completely unfamiliar in our solar system. This uniqueness makes it challenging to theorize what K2-18b is truly like. While we often compare rocky exoplanets to Earth or Mars and gas giants to Jupiter or Saturn, sub-Neptunes are a different story. There's nothing in our solar system to directly compare them to, leaving scientists somewhat in the dark, like a blind man trying to understand an object by touch alone. Despite these challenges, we have some educated guesses about K2-18b. We know it orbits a red dwarf star, known as K2-18, within its habitable zone. This implies that if water were present on its surface, it could potentially exist in liquid form, similar to Earth. However, its orbit is much closer to its star than Earth's orbit around the Sun. K2-18b orbits at just 0.16 astronomical units, AU, from its star. To put that in perspective, in our solar system, this distance would place it much closer than Mercury, resulting in a year on K2-18b lasting only about 33 days. In such proximity to its star, conditions would be extremely harsh compared to those on Earth. The concept of plankton on K2-18b is intriguing, especially considering the nature of its host star. Unlike our Sun, the star K2-18 is significantly cooler, allowing for a closer orbital distance without the risk of any surface water being vaporized into steam. This aspect is crucial, as recent theoretical research suggests that planets like K2-18b could be predominantly aquatic. In 2021, Professor Niku Mutahan, who is also involved in the potential detection of DMS on K2-18b, published a compelling study in the Astrophysical Journal. He proposed that sub-Neptunes might represent a novel category of exoplanets. These planets could be enveloped in global oceans under a hydrogen-rich atmosphere, a concept Mutahan has termed Hycean worlds, a blend of hydrogens and ocean. If such water worlds exist, they would be extraordinary by our standards. With up to 10 times the mass and twice the radius of Earth, they would experience extreme temperatures, potentially reaching around 200 C. Despite these high temperatures, the defining characteristic of these Hycean planets would not be a blanket of steam, but rather an immense ocean, making up about 90% of the planet's mass. This vast ocean, surrounding a relatively small rocky core, could, in theory, support simple microbial life. The thick atmosphere of these planets could provide additional interesting features, potentially creating a unique environment for life as we know it. The atmospheres of Hycean worlds like K2-18b could potentially increase the habitable zone around their parent stars compared to a rocky planet like Earth. This is somewhat akin to how Canadians might comfortably wear t-shirts in temperatures that others might find unbearably cold. Given the relative abundance of sub-Neptunes and this expanded habitable zone, Hycean worlds are considered promising locations in the search for extraterrestrial life. Their larger size also makes them easier targets for study from great distances. This is why Professor Mutahan's team used the James Webb Space Telescope, JWST, to observe K2-18b, a decision that might soon yield groundbreaking results in confirming the existence of Hycean worlds. However, the process of detecting these ocean worlds using even advanced equipment like the JWST is incredibly complex. In both January and April of 2023, the JWST focused on the star K2-18 for a total of 5 hours, divided into 2 sessions of 2.5 hours each. During these periods, K2-18b passed in front of its star, allowing the star's light to filter through the planet's atmosphere. This process is what enabled Mutahan's team to draw conclusions about the atmospheric composition of K2-18b. As the BBC reported, the light from the star carries the chemical signature of molecules present in the planet's atmosphere. This information can be extracted by analyzing the spectrum of the light, breaking it down into its constituent wavelengths to identify the chemicals present. In the process of studying exoplanets like K2-18b, scientists use a method akin to a prism, creating a rainbow spectrum. When analyzing the light spectrum obtained from a planet's transit in front of its star, certain frequencies might be missing. These gaps are due to absorption by chemicals in the planet's atmosphere, allowing researchers to determine its composition. This is how scientists identify the presence of specific molecules on distant planets. However, identifying these molecules is not as straightforward as simply examining the spectrum. Scientific findings are associated with a sigma value, which essentially indicates the confidence level of the researchers in their discovery. For the general public, a sigma value can be understood as a measure of the likelihood that the finding is not a mere coincidence or error. For instance, a 1 sigma signal suggests a high probability of error, similar to a dubious claim. A 2 sigma signal is more credible, but still carries a significant chance of being incorrect. When findings reach a 5 sigma level, they are almost certainly accurate, akin to an undeniable fact. Generally, the scientific community requires a discovery to have at least a 3 sigma confidence level to be considered credible. In the case of the JWST's observation of K2-18b, the detection of not confirmed the presence of water vapor with any significant confidence. This challenges the earlier 2019 findings by the Hubble Space Telescope, which had suggested the presence of water vapor but might have actually been detecting methane. The reason Professor Mutahan's team is intrigued by the possibility of K2-18b being a Hycean world is due to the combination of atmospheric molecules fitting the theoretical model of such a planet. However, this doesn't definitively prove the existence of an ocean. As astrophysicist and science communicator Elizabeth Tasker pointed out in a blog post, while we cannot confirm the presence of water on K2-18b, we also cannot conclusively rule out the possibility of an ocean. Science often involves careful consideration and a degree of skepticism. While it's exciting to speculate about distant ocean worlds and the potential for extraterrestrial life, astrophysicists approach these topics with caution. This cautious approach is particularly pertinent when considering the JWST's potential detection of molecules associated with life. In the near future, the JWST is scheduled to observe K2-18b again during a 2.5-hour transit of the planet across its star. Professor Mutahan's team plans to use this opportunity to increase the confidence level in their previous findings and possibly uncover more about this intriguing exoplanet. In their upcoming observations, Professor Mutahan's team aims to strengthen the evidence for their previous discoveries about K2-18b, focusing particularly on verifying the presence of a global ocean and redetecting the potentially life-indicating molecule, dimethyl sulfide, DMS. The James Webb Space Telescope, JWST, will play a crucial role in this endeavor, especially its mid-infrared instruments, which are well suited for detecting traces of DMS. The excitement surrounding these observations is considerable, as confirming the presence of DMS might suggest the existence of alien life forms. However, this enthusiasm is tempered by a healthy dose of caution. The reason for this cautious approach is that the initial detection of DMS was not highly confident, having a sigma value of only 1. This level of confidence is quite low, akin to the proverbial fake girlfriend in Canada scenario. As planetary scientist Joanna Bastow stated in an interview with Chemistry World magazine, the initial detection of DMS was extremely tentative. Even so, any indication, however tentative, of extraterrestrial life warrants closer investigation. Confirming the existence of space plankton or any form of life outside Earth would be a monumental discovery. It would suggest that life evolved independently of Earth, possibly implying its existence elsewhere in the universe. However, even if the JWST achieves a high confidence, 5 sigma detection of DMS in its next observations, this wouldn't immediately lead to declarations of extraterrestrial life. Scientists would first need to eliminate any potential non-biological explanations for the presence of DMS. While on Earth, DMS is primarily associated with biological processes, it's essential to explore all possibilities thoroughly before drawing conclusions about life on other planets. While organisms on Earth are commonly associated with producing dimethyl sulfide, DMS, this might not necessarily be the case on K2-18b. The reason for this is that Hycean worlds, if they exist, are fundamentally different from anything we're familiar with on Earth. When people hear about ocean worlds, they might envision a planet like Earth, but without the continents, influenced by depictions in popular culture, like in Kevin Costner's movies. However, Hycean worlds are much more bizarre and complex. Astrophysicist Ethan Siegel has elaborated on this in a piece for Big Thing. He explains that any planet more than twice the mass of Earth and with a radius 1.3 times greater cannot be a rocky planet like Earth. Moreover, any world with a radius exceeding 1.75 times that of Earth would be more akin to Neptune than our planet. And Neptune is a vastly different and extreme environment. It's a world where it rains diamonds, and the atmospheric pressures are so intense that they create what NASA describes as a hot, dense fluid of icy materials and an ocean of super hot water which remains liquid due to the extreme pressure. This Neptunian ocean is far beyond the boiling point and entirely uninhabitable by any known life form, resembling more of a hellscape than a habitable environment. If K-helium atmosphere constitutes even 0.5% of a planet's total mass, the surface pressure could be tens of thousands of times greater than on Earth, with temperatures soaring into the thousands of degrees. This means K2-18b is far from being an Earth-like world covered in oceans. Given its stark differences from Earth, we cannot simply assume that an Earth-based biosignature like DMS would indicate the presence of life on K2-18b. As Elizabeth D.K. puts it, a deeper understanding of the specific conditions on K2-18b is essential before concluding that a biosignature found on Earth could not be formed abiotically, non-biologically, in a different environment. Such studies are yet to be conducted for K2-18b or Hycean worlds in general. Despite these challenges, the JWST's continued search for DMS in K2-18b's atmosphere next year remains a thrilling endeavor. It represents a crucial step in advancing our understanding of these unique worlds. However, this also implies that the discovery of alien life, particularly on Hycean planets, might be more complex and distant than initially anticipated. This realization becomes even more apparent when considering the various challenges associated with studying these unique planetary bodies. This perspective was especially notable back in September 2020. Amidst the grim backdrop of the pandemic, a major news story broke, capturing widespread attention and offering a momentary distraction from the global crisis. During the lockdown period, a team of scientists made a significant announcement about detecting a molecule in the upper atmosphere of Venus, which is often considered a sign of life. This revelation sparked a media frenzy, with many outlets prematurely suggesting the discovery of life on Venus. This excitement even led to speculation that NASA's subsequent decision to send 2 probes to Venus as part of its discovery mission was influenced by this phosphine discovery. However, by 2023, the consensus in the scientific community shifted. There was no solid evidence to confirm the presence of phosphine in Venus's atmosphere. The initial 2020 findings were not robust enough to warrant such high-profile announcements. This cautionary tale is a key reason why the scientific community is now exercising extreme caution regarding the detection of DMS on K2-18b. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe. Live Q and a Sessions with Experts. Your membership will grant you the chance to participate in Live Q and a Sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.